All right, welcome back everyone. Let's look at the solution to the now you try problem that involves distance, speed, and time, where we can set up a rational equation and solve it to answer a question about the scenario. Let's take a look here. The winner of a 9-mile race finishes 14.73 minutes ahead of the second place runner. On average, the winner ran 0.6 miles per hour faster than the second place runner. Find the average running speed of each runner. Okay, I'm going to ignore everything except for the last sentence for a second. Find the average running speed of each runner. So we have two runners that we need to be paying attention to. Runner 1, let's say let S1, or let's use V just like we did in the last one. Let V1 equal the speed of the first runner. And V2 equal the speed of the second runner. And actually, we need to kind of adjust this because one of them wins and one loses, and we need to identify which is which. Let's let the first one be the winner and the second one be the second place. All right. We also want units for our speeds. This is a 9-mile race, and we're doing, we have 0.6 miles per hour, but we also have minutes given up here. Let's do the speed in miles per hour, just like it has in that context, and we are just going to have to watch our units, and we'll have to switch some stuff. So both of these are in miles per hour we're going to use for both. Okay. Now we have a 9-mile race. Both of them, let's do runner 1 here. Both runners are running the same distance of 9 miles. But the time for the first one is 14.73 minutes. We keep that units in here, less than, right? We're ahead of the second place runners, less than because they're spending less time, right? So that's equals T2. That's my first sentence. Right there. On average, the winner ran 0.6 miles per hour faster than the second place runner. Let's do this in red. So let's do this down here with this V1 and V2. V1 is V2 plus 0.6. So that's good to have there. So we just kind of want to use that relation now. The time for the winner is going to be the total distance over their speed. And what we're going to do for this is we're going to do V2 plus 0.6. And the reason that we want to do that, I'll leave it as V1 for a second, then we'll switch it. So 9 miles over their speed. And T2 is going to equal 9 miles over their speed, V2. But I don't want these to be different. I want to use the same variable in both. So I'm going to say T1 equals 9 over V2 plus 0.6, so that I don't have any more variables than I need to. Essentially, I can take this and plug it in right there. So that does add a little complication that we didn't see in the previous problem, but hopefully you're following that argument there. And there's a chance that you even got that figured out. Like the previous problem in the example, we had the speed downriver and the speed upriver being different based on the current working with or working against. And here we have two different speeds where one of them is 0.6 miles per hour faster than the other. So we put that plus 0.6 in right there. So it is similar in that way. All right, now the equation T1 minus 14.73 minutes equals T2, we need to switch that to hours so that all of our units match here. Move some of this stuff out of the way. Move this over here for a second. So let's take that. Oops. Actually, I'm sorry. I wasn't sure how I wanted to arrange this ahead of time. Let's take that 14.73 minutes and multiply this by 1 hour per 60 minutes, or divide it by 60, if you will. And let's see what we get here. Let's grab my calculator, and I'm going to do 14.73 divided by 60. And this is 0.2455. This is not a fun number, but that's how many hours that we're looking at. So this is T1 minus 0.2455 hours equals T2. So now our units are matching with the miles per hour like we want. So I can go ahead and plug in the T1 and T2 in red in for the T1 and T2 in the equation that relates them. So what we'll have is 9 over V2 plus 0.6 minus 0.2455 equals 9 over V2. And now we can solve this equation. Let's go ahead and switch our colors up here so that I can multiply both sides by our common denominator, which is V2 times V2 plus 0.6. And on the left, we'll distribute this across the minus here. So we'll have V2 times V2 plus 0.6 times 9 over V2 plus 0.6. We'll have minus V2 times V2 plus 0.6 times 0. You know what? Let's put that 0. Minus 0.2455 times the V2 times V2 plus 0.6. And then this will equal, on the right side, we can cancel the V2s right away. And we'll be left with 9 times V2 plus 0.6. All right, now we can start simplifying a bit. On the left side, our first term is V2 times V2 plus 0.6 times 9 over V2 plus 0.6, and we can cancel the V2 plus 0.6, top and bottom, leaving us with 9V2. The second term on the right side is minus 0.2455 times V2 plus 0.6. Here, it doesn't look like we're going to have anything to cancel, so let's just distribute. We'll get negative 0.2455 V2 squared minus 0.2455 times 0.6. And it'll be a V2 times, put the number in front, 0.1473 V2 equals, on the right, 9V2 plus 9 times 0.6 is 5.4. All right, let's see, I think I can subtract the 9V2 from both sides. That's nice. Cancel those. But I still have another V2 here. I have negative 0.2455 v2 squared minus 0.1473 v2 equals 5.4. I'm going to move everything to the right side since I have a squared term and a non-squared term. So I'll have 0 equals 0.2455 v2 squared plus 0.1473 v2 equals plus 5.4. And I definitely don't want to factor that, so we're just going to go to the quadratic formula now. v2 is going to equal negative b, negative 0.1473, plus or minus the square root of b squared, 0.1473 squared, minus 4 times a, 0.2455, times c, 5.4. Close up our square root, and then this will all be over 2 times a, 2 times 0.2455. I'll just go ahead and plug this into a calculator. I've got that pulled up right here. These are old. Don't need those anymore. All right, so I'm going to have a fraction, negative 0.1473. I'll do the plus first, square root of 0.1473 to the second, minus 4 times 0.2455 times 5.4, and over 2 times 0.2455. That says undefined. And that means that inside's not working out the way that it's supposed to, so something's wrong. Let's see if we can find it real quick here. Yep, I found it. So let's see, I went backwards, and this is an easy thing to do. T1 is the winner. They should have the smaller time. The T2 should have the bigger time. They're the second place finisher, so it should be T1 plus the 14.73 minutes, T1 plus the 0.2455 hours. Now let's see if we can just fix this without redoing the whole problem. So don't erase everything, just change those to pluses, then we'd have a plus right there and a plus right here. So it'll give us a plus right there as well, and a plus right there. All right, so we'll have a positive and a positive. So we'll just go and redo this bottom part where I'm now going to subtract the 5.4 from both sides. So that'll be a minus 5.4, and then everything here, b, negative b stays the same, plus or minus the square root of b squared minus 4 times a times c. The only thing that we need to do is change that to a minus 5.4 over 2a. That stays the same. Whew. Glad we didn't have to go back and redo any more than that. So always look for that. Don't always redo an entire problem just because something's not quite working. See if you can find a small error that can be quickly fixed through the whole thing. And here that changes this so that we get 4.3995. We will approximate that out to be 4.40. Or what happens if we change this? Let's duplicate and just change this to a minus right here. And that's a negative 5.0. But that doesn't make any sense for it to be a negative there. so we won't use that one. Okay, so we've almost got this all wrapped up here. V2 is 4.40, and so that's the speed of the second runner. Let's go back to the original question. Find the average running speed of both runners. So we can take then this and say that V1 is equal to V2, 4.40, and that's in miles per hour. And then let me just rewrite V2 real quick. V2 equals 4.40 miles per hour, and then the speed of the winner is that plus 0.6 miles per hour. So that's going to be 5 miles per hour. So we can conclude then that the winner was running 5 miles per hour, and the second place finisher was running 4.40 miles per hour. That's it. And we're done. All right, thank you so much for watching, everyone. I know this one was a little tricky with needing the quadratic formula, having these decimals, but that's how real life works. That's the kind of numbers that we would be running into. So just work through the problem using the same motions. Don't be scared of those slightly strange numbers. Just take the time to work with them. Be careful how you plug things into the calculator. You're going to be just fine. You guys have made it this far. You've done absolutely fantastic. Thank you so much for watching, and take care.